Hello everyone. Today I'm going to present about my Smart Study Planner, which is a program I wrote for my computer programming class. This Smart Study Planner is an intelligent Python-based system that uses natural language processing and time series forecasting to transform student-entered goals, deadlines, and tasks details into an optimized, balanced, and fully visualized study schedule. In this presentation, I'll be going over the objectives, a demo showcase, the evaluations, and additional credits. The objectives of this project is to aim to automate the study planning process by analyzing tasks, deadlines, and user goals using natural language processing to extract priorities and time series forecastings to estimate study time needs. This generates a balanced daily schedule, visualizes study patterns for clear insights, and allows students to export a complete weekly plan for their convenient use. The process of this is fairly simple. First, in order to create a automated study scheduling, this program will need to analyze the tasks and deadlines set by the user, and also extract the goals using natural language processing. After that, it will forecast the study time needs and balance the daily workload. This can also generate a PDF version of a graph of a study pattern and export the weekly plans the students should follow. Now I'll show you a demonstration showcase of how this program works. First of all, run this program in VS Code. Over here, you can see a list of tasks this program can do for you. I'll go through each of it. First, you can add a manual task. This will allow you to select a subject, the task description, and the deadline, where you can enter any date. After this, it will tell you to estimate the number of hours it takes for you to do this and the difficulty. It will show that the task is added. Next, I'll add another task for it to be easier to look at. Now I will show you how to add a natural language goal. An example of a natural language goal is revise calculus quiz before Thursday. Next, by choosing option 3, you can see your tasks and goals. It will show you the subject, the deadline, number of hours, the difficulty, and how close your task is until the deadline. This next option will allow you to edit a task. As you can see here, I will edit my second task, which is calculus. As you can see here, I have edited my new subject, description, deadline, estimated hours, and the task difficulty. Next, I'll add a manual task just to show you how to delete a task. So here, after you pick delete a task, it will show you the task list, and you just choose the number you wanted to delete. Here, it will show you the graph, which is done using matplotlib. So this generated study schedule will show you your daily hours and the date and how much you need to study for each. This graph is auto-generated based on what the student have entered. And finally, type 7 to exit this program. So the list of libraries I have used is Pandas, NumPy, Matplotlib, NLTK, and FPDF. I use Pandas to keep track of and arrange my study objectives and tasks in organized tables and data frames with features like subject, task, description, deadline, expected hours, and difficulty. I use NumPy to divide study hours proportionately across available days and to compute task priorities and execute the numerical operations. Next, I use Matplotlib to produce bar charts that show the distribution of the workload, the weekly progress, and time allocated to each topic, giving a clear picture of the study schedules. And I use NLTK to evaluate the user inputted natural language objectives and to extract the important details such as subject, task description, and projected hours, and transform unstructured text into the structured data for scheduling. Finally, I use FPDF to export the created weekly study schedule and to complete with the organized tables of assignments, due dates, and allocated study times as a PDF. So to sum it up, the main components I have is libraries used, which are Pandas, NumPy, Matplotlib, NLTK, and FPDF, and some built-in functions. Some built-in libraries are datetime and OS. And this main program has around 400 lines of code, and the core components are natural language processing and tokenizing stop forward removal and keyword extraction, and also task phrasing and validation, and also priority scoring logic, where I have to score the priority of each subject and how important each task is. There's also a automated scheduling engine, as well as visualizing functions and a PDF export generator. The main challenge with this project was the natural language processing difficulties, because it was really hard to interpret the vague user goals, and it was hard to create rules to detect the subject's deadlines and estimated hours. This means that I have to take into consider what students would usually type out as their task, and I have concluded that the main three things are the subject, the time, and how important it is. And this also uses the another main challenge is the scheduling logic complexity, because I really had to distribute the study hours evenly across available days and ensure that the tasks don't overload a single day. And I'll also use ChatGPT and AI to structure, debug, and organize the coding to make this process more simple. Thank you for listening to my presentation.